Namaste students, welcome to the digital session of Jayoti Vidyapeeth Women's University. And this class is for B.Sc, B.Ed, B.Sc in 8th semester. The topic that will be covered in today's session is liquid drop model. In the last session, I discussed about the similarities of a liquid drop with the atomic nuclei. In this session, I will discuss about some of the dissimilarities that are present in a liquid drop and atomic nuclei. Okay, so the first point is in case of atomic nuclei, there are nuclear forces inside the nuclei which are short range force and are always attractive in nature. Okay, these are short range forces and are attractive in nature. But in case of liquid drop, there are molecules inside the liquid drops and there are attractive as well as repulsive force present in case of molecules. So this is one of the basic difference between liquid drop model and atomic nuclei, that in atomic nuclei there are only attractive forces, whereas in molecules or in liquid drop there are attractive as well as repulsive forces also. The another difference is the average kinetic energy of the molecules in the liquid is of order of 0.1 electron volt. And by considering this energy, we calculate the corresponding de Broglie wavelength, and it comes out to be 0.5 into 10 raised to power minus 11 meter, okay, which is quite small. And when in case of nucleons, we take the average kinetic energy which is of order of 10 mega electron volt and then calculate the corresponding de Broglie wavelength, which is this. Okay, so we can see here that the value of the de Broglie wavelength in case of liquid drop and atomic nuclei is quite different. Okay, well, this is much smaller as compared to this. Okay, so 10 is to power minus 15 is smaller than 10 is to power minus 11 meter. So and the motion of liquid is of classical nature, and the motion of nucleons is of quantum nature. Okay, so at this level of small scale, there comes quantum mechanics into the picture. So the motion of nucleons will be described by quantum mechanics, and this can be described by classical mechanics. There are some failures of this liquid drop models. You just need to remember these points. Okay, so first point is this liquid drop model fails to explain the extra stability of certain nuclei. Okay, we already studied that certain nuclei whose mass number are 2, 8, 28, 2, 8, 20 are extra stable. Oh sorry, we haven't yet studied about these. There are certain nuclei which are extra stable. Okay, and the mass number of these nuclei are 2, 8, 20, 28, 50, 82 and 126. You need to remember these numbers. Okay, these are called magic numbers. The nuclei having the mass number equal to any magic number are extra stable. So this model, this liquid drop model, fails to explain the extra stability of these nuclei. Next point is it can't explain the measured magnetic moment of many nuclei, and it also does not explain the spin of nuclei. Okay, the next point is it is not successful in explaining the excited states in most of the nuclei. Well, you just need to remember these points if it is asked in the exam that what are the failures of liquid drop model. So you need to write all these. So don't go much deep into these, just remember these. Next point is the agreement of semi-empirical mass formula with experimentally observed masses and binding energies is poor for light nuclei as compared to the heavy ones. Okay, so this is the next topic we will study, which is semi-empirical mass formula. So you will understand this point later. So these are some of the failures of the liquid drop model.